The topic here is the u-substitution for integrals. So, like we know, the power rule for integrals is integral of xn dx is equal to xn plus 1 over n plus 1 plus c. But if integral of un du is equal to un plus 1 over n plus 1 plus c, here u is some function of x. U is equal to u of x. So let's do an example to stress out about the u substitution. So here we need to, for example 1, we need to evaluate integral of 3x plus 1 to the 6 dx. So what we do, everything that's between parentheses, we always call it a u. So this is going to be my u. In other words, the u is going to be equal 3x plus 1. Now what does this mean? This means that du over dx, right? If you take a derivative, you'll get what? Du over dx of 3x plus 1 is 3. What does this mean? This means that du is equal 3 times dx. I think of this as being 1. Du times 1. Du, right? Multiplying this way. Du times 1 is du is equal to dx times 3. This is 3 dx. Now what we do, we solve for dx. So dx is equal, divide both by 3. You get du over 3. So this is the method. We always going to need the u, the substitution, u equal 3x plus 1. And we always need to solve for dx. Now all we need to do is just replace. So let's call this 1, or let's do this. Integral of 3x plus 1 to the 6 dx is equal. So we replace 3x plus 1 by u. So this becomes u to the 6. And my dx is right here. It happens to be du over 3. Now remember, you can always take a constant outside. If we take, these are 1 here, right? If we take 1/3 outside, you'll get 1/3 integral of u6 du. Now we can use this integral. We can use this property. So we know that so this is going to be 1 over 3. We know that integral of u to the 6 du is equal to u, 6 plus 1, 7 over 7 plus some constant. We're almost done. Remember, this is an integral of a function of x, so all we need to do is replace u by its value. First of all, 7 times 3 is 21, right? So 1 over 21, u is right here, 3x plus 1, so 3x plus 1 to the 7 plus a constant, and you're done. Alright, example 2. So let's do example 2. Evaluate integral of 5x squared times 6x cubed plus 8. Well, this will be easy to FOIL it, so let's change the problem. Let's make this to be like the exponent to be 10. So let's do this problem. 5x squared, the integral of 5x squared times 6x cubed plus 8 to the 10 dx. Again, wherever is between parentheses, we're going to call it a u. So my u is 6x cubed plus 8. Now remember, du dx is equal 18x squared. Now du is equal 18x squared dx. And remember, we always solve for the dx. So if we solve for the dx, this is the same thing as du over 18x squared. I'm trying to do it the easiest way. So always solve for the dx. And then the only thing we need is the u and the dx. But remember, our goal is to have integral just to u, some function of u and du. So we want the x to disappear and the dx to disappear. We want all of these to disappear and the dx to disappear, and we want to have just the u's. So this integral is equal to 5x squared, I'm going to leave it for now, 6x cubed plus 8 is a u, so u to the 10. And the dx is right here. It's du over 18x squared. Remember, we want just the u and a du, but of course the x squared is gonna go. So you simplify x squared with x squared, and then 5 over 18, we can take it outside because it's a constant. So this will be u10 du. Now we can use the power rule for u. So this is going to be equal 5 over 18 u. 10 plus 1 is 11 over 11 plus a constant. Now this is equal to 18 times 11 is 198. So 5 over 198 u 11 plus c, which is equal 5 over 198. Don't forget to replace a u by 6x cubed right here, 6x cubed plus 8. So this will be 6x cubed plus 8, everything to 11 plus c. So this will be the answer. And we're done with this example.